Solubility product constant. What we're going to try to do with this lab is to become aware of the solubility product constant and to estimate a solubility constant, and also to observe the solubility constant in it is a special case of an equilibrium constant. Let me show you what it all means. All right, first thing what you're going to need is you're going to need some calcium nitrate. Okay, wait, that's copper nitrate. Here's calcium nitrate. And some sodium oxalate. That would be this guy right here. You're going to need a 96 well reaction plate, a mini pipette. So that would be, here's my regular pipette. Actually, is this graduated? Yeah, this is a graduated. Here's my regular pipette, or my graduated pipette. Here is my regular pipette. This one right here with a really thin end, that's a mini pipette. Now, what you're going to want to do is we're going to first assume, and you also need something dark, a black sheet of paper, or in this case, I have a book. There we go. This book will do. Okay, I have a book, has a dark part over here, so I can basically put this onto here and then look through it, and I have a nice dark background for me to be able to see behind it. And I also will probably need one of these little plastic toothpicks over here. So here's how this experiment is done. What you're going to want to do is we're going to assume that the one drop from here, this mini pipette, this little tiny piece right here, is about half of a drop of what this thing can give. Now, what you're going to want to do is in well A1, you're going to want to put 5 drops of the calcium nitrate. So that would be 1, 2, 3, 4, 5. All right. Now, the molarity of this calcium nitrate is, you can see right there, it says 0.1 moles, or molarity. So 0.1 moles per liter. Now, what we're also going to do is we're going to take distilled water and we're going to put 4 drops in wells A2 through A7. So I'm going to skip well A1. I'm going to go A2, 3, 4, 5, 6, 7, 7. I'm going to put 4 of these drops into there. Okay. 1, 2, 3, 4. There we go. Actually, to be honest with you, this is a lot harder to use than this one. And it's the same stuff. This is distilled water. So let me just kind of... 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 4. All right. It doesn't necessarily matter the speed that you drop it at. If you do a really slow drop or a fast drop, a drop is a drop. The thing is, I can probably go faster just because I'm used to doing these. I would go slowly for you because you don't want to drop 5 drops if you're trying to only drop 4. You can't undrop a drop. It's very difficult to kind of do that or even think about how to do that. All right, the next thing you're going to want to do is, we know that the liquid in well A1 is 0.1 mole of the calcium nitrate. Well, 2, 3, 4, 5, and 6, and 7 have pure water in it, and so there's nothing in there. So what I'm going to do is I'm going to suck up some liquid into here. Okay, you see the liquid in there? All right. Now I'm going to put 2 of these drops. So this is going to be assumed to be... Okay, where is it? 1. Oh, I didn't grab 2 of them. Okay. And 2. And I'm going to put the excess back in well number A1. So I'm going to put the rest in well, anyway, I'm going to just kind of squeeze it all in there. There we go. All right, now I'm going to mix up well A2, and I'll show you how I'm going to do it. I'm going to just take it, suck up some of the liquid, put it back in. Suck up some liquid, put it back in. Do it one more time. There we go. All right, now what I'm going to do is, now, to be honest with you, I can't get every single little bit of liquid out of here, out of the inside of this. And don't worry, they've already calibrated for that. So you don't need to worry about getting every single micro drop of liquid in there, back inside there. And what I'm going to do is I'm going to suck up some of the liquid. I'm going to put 2 mini drops in well 3. 1, 2. All right. So I went from a pure solution to a less concentrated solution, diluted by 1/5. And I diluted that by 1/5. So I'm going to mix it up just by sucking it up, putting it back in, sucking it up, putting it back in. That should mix it up real nicely. Then what I'm going to do is I'm going to suck up some of the well 3. I'm going to put it in well 4, so it's 1, 2. That should be assumed 1 full drop, and then I'm going to put the rest of it back in well 3, and I'm going to mix up well 4. I'm going to keep on doing this procedure. 1, 2, until I get to well number 7. Okay, almost there. 1, 2, and then put the rest inside of well. So what I mean is I'm putting the excess back in well number 5. So I put some in well 6, and then I put all the rest of it that's left in here back in well 5. And then I'm going to mix it up. I'm just about done. 1, 2. Put the rest back in 6. Mix it up. And then what I'm going to do is I'm going to take 2 drops out of well number 7. I'm just going to throw it away. 1, 2. I'm going to put the rest back in well number 7. So there. That should have been consistent all the way across the board. And if you look at it, which you can't see it, but I can see it, they're all pretty nicely at the same height. Okay. So what we have is we have 0.1 moles, and then we divided that by 5, so now we have 0.2 moles, and we divided that by 5, and so we have now 0.004 moles, and so on and so on and so on. Now what I'm going to do is I'm going to put 1 drop of the sodium oxalate inside of wells A1 through A7. So I have the most concentrated version of calcium nitrate in A1, and then I'm going to put 1 drop in each of the wells A1 through A7. So I'm kind of putting 1 drop to a less and less concentrated version of calcium nitrate. So I'm just going to put 1 drop in each. 1, 2, 4, 5, 6, 7. There we go. All right. And I'm going to stir it. I can even use the toothpick a little bit. I'm going to douse this with some ionized water, ionized, but distilled water. Stir it, douse it, stir it, douse it. And from this, I can observe whether a reaction took place. Now, one thing you can do is I would put this up against a black paper or something dark so you can kind of see, and I can actually see some reactions taking place. Another thing you can do is, okay, wait 1 second. Okay, another thing you can do is hold this up to the light, and maybe you might be able to see it a little bit better that way. And so basically now you can observe the reactions that took place in this case. Cool. Now the most important thing is the cleanup. Again, this is very, very diluted concentration, so I can just dump this straight inside of the sink. but I use lots and lots of water because I don't want to do anything bad for the environment. And then what I always like doing is, there it is. I'm going to take my distilled water and then I'm going to spray it inside here like this. There we go. And I'm going to put this upside down someplace where it can dry. All right, so now you have to answer the questions and write up the lab report and make your observations, fill in the table, maybe make a graph or two, and I hope that helps. Aloha.